Let's do some simple Lewis structures. If you have not already read the material at the top of the page, you ought to pause this and read through this, and also look at the material that's in your text. Let's do the first application, about carbon tetrachloride. The first step is to count up the total number of valence electrons. Carbon is in group 4, so it has 4 valence electrons. Chlorine has been put in group 7 because it has 7 valence electrons. We've got 1 carbon, 4 chlorines. That means we have to show 32 electrons. No more, no less in our Lewis structure. The central atom will be carbon. It's the one that there's only one atom of. And nature likes symmetry as much as possible. So we will bond the 4 chlorines to the carbon. Each line represents a bond. A bond represents 2 electrons. We've drawn 4 bonds. That means we've drawn in 8 electrons. We have 24 left that we can still draw. Now we need to disperse those electrons around the chlorines. 2 ways of looking at it. One is to count the number of valence electrons that each chlorine needs. Chlorine has made a single bond. It has 2 electrons. To finish its octet, it needs 6 more electrons. So if this chlorine needs 6 more electrons, so does each of the chlorines. 4 6s are 24. We just happen to have 24 electrons left to draw. So we can put those in as dots. And voila, that will be the correct Lewis structure. The way the directions up above talk about doing this is you put enough dots to give everything an octet until you run out the dots that you had, the electrons that you had. And so we would go in and put 6 electrons around each chlorine until we got to 24, and it would just work out that that would be the exact number that we need. So that was for carbon tetrachloride. The next one is for ammonia, NH3. Nitrogen is in group 5, has 5 valence electrons. Hydrogen has its single valence electron. We've got 3 of those, 1 nitrogen. So we'll have 8 valence electrons, no more, no less. What's the central atom? In this instance, it's the nitrogen because it's the element that has only 1 atom of its type in the compound. We'll draw a skeletal structure, which means drawing a bond between the nitrogen and each hydrogen. We've drawn 3 bonds at 6 electrons. That means we only have 2 left to go. And we now need to distribute those electrons. Hydrogen, in order to get its quote-unquote octet, which really means to get a noble gas configuration, all it ever makes is a single bond with 2 electrons. The nitrogen only has 6 electrons around it, so we can draw in those 2 remaining electrons, and that will wind up being the correct Lewis structure for ammonia. The next one is water. Hydrogen, group 1, we've got 2 of those. Oxygen, group 6, and we got 1 of those. So once again, this one only has 8 valence electrons. The central atom will be oxygen. That gives us the most symmetrical skeletal structure. We've drawn in 4 electrons. That means we have 4 more that we can draw in. The hydrogens are good. They don't need any more electrons. We've got 4 electrons. We can put those on oxygen, and that will give it its octet. So that's the correct Lewis structure for water.